Hello everyone, happy afternoon. I just had lunch and now I'm ready to tackle the Game Boy audio nonsense again. And oh boy, oh boy is this proving to be difficult. We have some audio waves generating. Obviously it's not like generating what it's supposed to be generating, but something is happening. Um, I'm not really sure what we need to do. We already validated that this sample code gets called 48,000 times a second, which is essentially the frequency at which the wave file needs to be generated. So this part here is well done. We also have this tick function, which we already know is called at 1,000,000 times a second. And the odd thing that is happening, okay, is that we should be updating this self.sample value every once in a while, you know, and whenever we actually write it to the wave file, it should look proper, but instead it's coming as these like thick gaps we have here, you know. So we kind of need to figure that out. Hello Simon, good afternoon. Easy to see a lot of apps get audio stutter when it's trying to do it 48,000 times a second. Yes, it's very difficult indeed. Yeah, I'm not exactly sure what we need to do here. I'm pretty certain. Okay. I'm pretty famous last words. I'm pretty certain that whatever is wrong is like these lines here. Somehow what is wrong is between these lines here. One thing that I know, which might be the thing causing the issue. Okay, let me. I would say that overall the issue is timing, as it is obviously every single time. But I would say that overall the issue will be timing, in the sense that the APU doesn't run. Let's assume that this is like the line of time, like the timeline. The APU doesn't run at 1,000,000 hertz, like at the proper sequence, you know, like every nanoseconds it runs once. No, that's not how it works. What it happens is that we have the CPU, and the CPU guy is actually running at kind of a regular pace, and then it does a sleep here, and then it runs at regular step, and then it sleeps a little bit whenever it frame ends. Okay, and each time it runs, it will run, or every time it executes an instruction, that instruction will take a different amount of clock cycles. Okay, sometimes if it's an OOP, it's 4 clock cycles, which means that the APU triggers once. But sometimes it can do like an hardcore jump, which is 50 clock cycles. And that means that I should run the APU like 5 times very, very quickly. You know? And then sometimes it goes back to 4, which is 1, and then it can do like 8, which is 2. So as you can see, like the APU is not steady at all. But then we have our wave rider here, which is the same thing as outputting to the speakers, you know. And the weird thing about this, well, it's not weird, but the thing about this wave rider is that it runs at a specific cadence, you know. It runs at a specific cadence, but whenever it gets called, it actually wants like several entries inside, which in this case is like around 2000. Don't ask me why or how, I just know that it's 2000. Every time we tick, we need to write 2000 bytes into a buffer. But these bytes are equally, or the bytes that you need to write are equally spread. Okay, they are equally spread. Okay, let me think what I need to say next. They are equally spread in time. So because we are only writing the last value for the APU, you know, it might happen that whenever we actually trigger these 5 times, because again this is running at 1 million hertz and this is running at 48 kilohertz. Whenever we trigger the APU 5 times, the APU should generate 5 samples. But all of these 5 samples kinda need to be stored in order to be written by the wave rider whenever the wave rider requests them. But in reality, what is happening is that we are, every time these ticks, or every time like we tick here, we are pretty much writing the same value inside. You know? Kinda. That's my theory for the problem. Now, what do we actually need to do here? I'm not exactly sure. But what I would say is that we need to somehow convert these samples, like these weird samples, 1 million samples that we do here, but they are not done at the same cadence. They are like bursts of 5 or 10 or 1 or... But we need to generate this burst of samples. And we need to somehow store them in a way that when the wave rider requests them, we have like an history of the last 0.1, I'm just pretending, but like as if we had a history of the last 0.1 second that we need to write into that buffer instead of the last value that we have. So I did some reading, and they actually have it. I saw a sample on CPOL, but where they essentially they have like a circular buffer that they are always trying to read and write from. So I wonder if that's kind of the thing we need to do here. I have absolutely no idea. Yeah, see, we have like this ring buffer here, and then we have a producer, consumer, and then we kinda can generate things at different frequencies. I don't know if we need to do this. Maybe, I mean, this is what they suggest us to be using. Classic exhaustion. Yeah, I think that's kind of what's happening. And whenever we get these bursts of stuff, it's because the APU, the CPU, the APU. Okay, so the wave thread is the only one that is running at like a specific cadence. You know, like these ticks here on the wave thread, they are called like at the proper time, but anything else on the emulator isn't, and I kind of need to normalize that somehow. So yeah, there will be pointing times where this guy doesn't have any data to read from there, so it's just gonna write like a big wave instead of trying to repurpose all the data, and does like boop, 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 you know. That's what I think it's happening. That's what I think it's happening. So how do I actually wanna tackle this, you know? How do I wanna actually tackle this? I don't know if I wanna go with this ring buffer or circular buffer. I kind of think we can do it with a regular vector, you know? I kind of think we can do it with the regular vector. But essentially, the thing is that my theory is that whenever we generate this sample here, instead of writing this sample, we do push. Okay? We push this sample there. Somehow we push it. Okay? And then whenever we call the sample from the audio thread, we'll do a, well, it's not really a pop, it's more like a remove first, you know, something like that. So yeah, it's essentially a queue. Yeah, I think I'll need a queue. So a philo, first in, first out. Yeah, it needs to be a FIFO. It needs to be a FIFO, so it needs to be a queue. You know? Okay, so can I create like a queue here? I don't even know if Rust has a queue. Vec the queue. Okay. So we'll need a vec the queue of floats. I don't know if I'll need capacity. I really don't care. Still have the sample here. Okay, and then here I'll double-ended queue implemented with a global ring buffer. Oh, so these already provide me a ring buffer. Pretty cool. Okay, let me see how the... Does he have like an in queue? No, he doesn't insert at an index. That's not what I want. I have an append. This just merges to... Okay, how do I actually like insert into this thing? Contains drain front get insert. No, insert takes an index. Prepend push. Okay, there's a push front and a push back. So do I push to the front and poop for and pop from the back. Or do I push from the back and pop from the front? Whatever. Do I push from the front and poop? Ay, ay, ay. Yeah, I meant pop and said poop. Very funny. Funny indeed. Okay, push, front, pop, back. I think that's the plan. Pop back. Okay. Now, this pop back will return me an option. Okay. Just in case this starves, right? Surely. Just in case this starves. Now, do I actually want to be generating this? Actually, I don't even know. Okay, will this work? Unwrap. This will probably grow like crazy, by the way. I need to keep an eye on my memory usage because I'm pretty sure this would like annihilate my computer. Okay, it crashed. GG. APU step. Oh. Pop. And wrap or 0. Yes. Okay, memory goes not too terribly. Okay. Oh, I need to exit from there. Okay, pretty cool. Okay, it kind of looks better. It kind of looks better. You know? I don't know about you guys, but I kinda like this a little bit more. Well, at the very least it's more wavy, you know? But I still think this should be I still think this should be more well, okay, there's one cool thing happening here, which is the first section here. Well, if I move it more like this, maybe. But this first section here, this first one, kind of matches the. I don't know if it's easy to actually understand, but here where I have my mouse cursor now, it's where it changes from the first frequency or the first tone to the second tone. So at the very least, we can see that something changed. I don't know if it's better or worse, but something absolutely changed. They kind of feel like the same spacing and not tighter. This is just running for more time for some reason. More ticks, which makes sense. But this should be tighter. Okay, but this should hopefully play something. Okay, brace yourselves. Oh! Oh no, this is because it's playing the other one. Sorry, I need to mute it. Ay, ay, ay. Okay. Okay, got excited there. Yeah. Same. Same. Sad. Sad face. Sad face. Okay. Now, okay, so I would say that whatever we had in terms of whatever we had in terms of I don't even know what I was gonna say. Doesn't matter. Okay, what if I put a 1 here? Okay, so here we can see when things are getting starved, you know? Here we can see when things are getting starved. What does it mean? I don't know. So it's getting starved there for some reason. Okay, so we need to somehow continue to generate data. We need to somehow continue generating data. So I would say that we probably don't want to only generate data here, right? We probably want to, I don't even know. We probably want to what? Here I want to tick this. I only want to tick this whenever it finishes the period divider, I think. But I shouldn't only push data there. Okay, so I wonder if I actually need, like on the waveform, like maybe I should just tick this here, which is essentially just whenever I tick this, these returns that value there, you know. And then maybe I'll need a like a sample, and sample just calls this thing here, you know, something like this. So the only thing that tick does is incrementing the index and looping it around. And then whenever I call sample, I use the same index to return the data. So here I would call tick. I'm just trying to see if I could like fill in the blanks somehow. And here will be sample. Hola campeón, ¿cómo andas? Hola Fran. ¿Qué tal? Muy bueno. Muy bueno. No, I'm having tons of issues with the Gameboy emulator, the audio implementation. I mean, it's doing something. The bottom lane is the audio that I'm trying to output, and the top line is kind of what it should sound like. This is like an MP3 of the actual Game Boy generated sound. So I'm trying to make both kind of match, you know. That's what I'm trying to do. Okay, so this will generate like a bunch more data here. Now, should I actually only generate this data this amount of times? Probably not, because this will generate 1 million of them. But I'm only grabbing them at 48,000 hertz. Right? So... I mean... So what do I need to do here? I mean, this looks smooth now, somehow. You know? It kind of looks smooth. But this is way too long now. How have you been, Fran? How's the AI NPC project going? Have you continued working on that or not really? 0.17. Okay, so I'm doing, instead of 0.17, I'm actually taking oh boy. Burp. Sounded like someone crapping themselves. 3.8. So this is like 20 times longer. This sounds like wearing a orange, but well, if you say so. I mean, this kind of sounds cool. Kind of satisfying, yeah. Kind of is. But now this is way too long. You know? Way too long. So this needs to tick faster. That's what I think should happen. This needs to tick faster. So how do I make this tick faster? I don't know. Either that, or I shouldn't push this many samples. Well, actually it's both, right? Like it needs to tick faster. Now, I mean, if I remove the samples, it should work. So I shouldn't be outputting 1,000,000 samples. I should be outputting 48,000 samples here. So how do I do this? How do I do this? Any thoughts? Any prayers? So I already have this weird counter. Okay, so I'm gonna get rid of these counters. This counter stuff is just obnoxious. But okay, do I actually have this sample clock here somewhere? Config dot sample rate. Okay, maybe I'll call it sample rate. Sample rate. Okay, so this hopefully should return me whatever 48,000 is. Okay, cool. So what do I need to do? So if I am generating 1 million, or I'm calling tick 1 million times, but I only need to actually generate 48,000 clocks, or 48,000 samples. It means that I should, I mean, this counter probably needs to be a U32. Add this to radio, please. Let me check. What the fuck is this? Holy. Damn. Yeah, I don't think I will, but thank you. It's like being inside a frog's intestine, yeah. And it sucked the entire time. And it smells, you know. I could smell it just from hearing it. Do it. Okay, hold on. So this runs this, okay? What happens if I do this? 21.8. I mean, there's a big possibility that this is gonna kill the audio. Like mute the stream or something, you know. Okay, it has been added. Okay, so I think I'll need to store this thing here. Const APU clock hertz U32 equals this 1 million and that. Cool. So much code that I can delete. Good job. Okay, counter is gonna be 0. Sweep, blah blah blah. Okay, so whenever I do this, so I have this number here. I also have the self.sample rate. Oops. I mean, might as well make this a float so it's easier to do this nonsense. So do I need to divide the APU clock hertz by self.sample rate? You know? And if self.counter is greater than this, I output this. Is this what I need to do? Maybe. Did this actually change something? No. Fuck. Oh, I need a self.counter equals 0. Duh. Okay. Let's try again. Kinda looks like something. It kinda looks like something. Oh, and it switches, it changes like the pitch at the proper time now. Holy. Please. I've been a very good boy. Holy crap! Never mind like sounding super loud, but it sounds like the thing. Indeed, it sounds like the thing. Holy shit. Okay. 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 Okay, I think there's like some weird artifacts whenever I'm doing this 0 here. So I wonder if I should also like store like the last sample or something. You know, so that I, at the very least... Well, or maybe I shouldn't ever DQ it if I only have one there. Maybe. Instead of a pop back. You know, I could do a let sample equals this. No, hold on. If self.samples.empty, I return 0. Just at the start, you know, just so it doesn't crash here. If it's not empty, I have a sample there. So then I need to check again. If it's empty, I add it back. You know, I add it back. Just so at the very least I always have one. Oh my god, unwrap. Push front. Found. No, it's this. Okay, and this should make sure that I always have one thing there. Okay. Okay, it doesn't look too terrible. It doesn't look too terrible. I mean, this... Okay, can I actually like move this here? This matches perfectly, you know? Like the change of pitch. Look at this. Like this matches perfectly. You know? This. Pretty awesome. Then it's not as steady here. But I mean, whatever. But this is great. Okay, can I actually like validate if this has the same? It kind of has, kind of hasn't. Well, it's cool that it starts as negative, you see? Like you can literally see the thing here. Although they have like a smoother in and out. Because they use I think it's a high pass filter. So it kind of smooths things over. Damn, this was a difficult sentence to pronounce. But I mean, overall the timing is kind of there. I mean, here we missed one for some odd reason. But all in all, this it kind of looks legit, you know? This kind of looks legit. Okay, cool. Pretty cool. So I think I can get rid of this thing here. Okay, so now what do I want to do on the waveform? I mean, I probably want the waveform to go from -1 to 1. -1 to 1. And this is assuming that -1 and 1 are like max volume for some reason. I'm not exactly sure how I should like control this. But all of this part here is done on the square channel. The thing is that this is the value for the waveform. And now I kinda need to also get the waveform value. It's gonna be this. And now I'll also need the volume value. It should be something like this. And then I would need to somehow modify this value. So if value is U8, so do I just assume that max volume is a... How do I know this? Okay, so if I do let volume ratio equals, because I think that max value is like 15, you know? Self volume dot volume as F32. So then here I probably want to do waveform value times that volume ratio, like something like this. And hopefully we will see like the volume decrementing. Absolutely not. Absolutely not. Okay, so are we not modifying this volume at all? We kinda should, you know? We kinda should. Okay, so whenever we are ticking this envelope, maybe we are just also ticking these like in the wrong spot, you know? It's fairly possible as well. Okay, so self.volume is 15. $14, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year! Fuck. Okay, but like, volume is 0 now, you know? So surely... Oh, it's the other way. Divided by 15. You know, like surely. Oh, I mean, it's kind of doing it. It's kind of doing it. Okay. Brace yourselves. This is gonna sound loud. Pog. Fuck yeah. Okay, pretty cool. Hell yeah. Hell yeah. Now, I don't know if this is way too loud or not. I'm not exactly sure. How should I control this? But I mean, this kind of matches, you know? This kind of matches. Yeah, so if I do this like this. Yeah, like it kind of disappears around the same time. But it feels like it's maybe way too loud for some reason. So maybe the waveform, instead of being this, maybe it's literally the alpha waveform. I don't know. I would need to do like some manipulation on this. But I would say that this is kind of working, you know? Okay. And now for the great reveal. Fuck, I closed the scratch file. Yeah. I closed the scratch file. Well, I kind of don't need it. Whatever. But now for the big reveal. Whenever I'm doing this sample here, now if I remove this line of code and I click play, my own Game Boy should play that sound. Okay, are we ready? All four of us? Okay, let's see. Play. It's fucking glorious. It's freaking glorious. Hell yeah. Okay. Oh! This feels like it's playing like parts of the music, you know? Pretty cool. Pretty cool. Okay. We keep going. So, I think that now, for the second channel, the second wave channel, I mean, this is mostly correct, you know? Mostly correct. This is mostly correct. So now for the other square 2 channel that we'll need to enable as well, you know, we'll need to create this guy, channel 2. Okay. Okay, I'll say that sweep is gonna be none. Maybe sweep. Gone. Maybe sweep none. Okay, and I kind of need to update now the addresses for these. Okay, so length timer and duty cycle. Nah, hold on. Okay, NR11 is a duty cycle. So this needs to be 16. Then you have 12. 12 is volume and envelope. Gonna be 17. And then 13 and 14 are the period ones. Okay, so I'll actually need to pass on the period counter or the period addresses. Okay. Okay. Maybe sweep dot and wrap as ref. Not more. Okay, it's mutable. Gonna be channel to tick. Is gonna be channel to enabled, channel to length enabled, channel to tick length. Channel to sample. Okay. I mean, this doesn't have one. Frequency sweep. Only channel 1 has it, so this is fine. Sound length. All can have it, I guess. Length timer, yeah. Envelope sweep. Okay, I'll need to do the same thing for channel 2. Okay, and this needs to be a channel to control. Square wave. Okay, so I kind of need to update these addresses here, like the period addresses. So how do I want to do this? Period control addresses. This is going to be a pair of U16s. Okay. Okay, and then maybe I'll do a 13 and 14 here. And for this guy, gonna be 18 and 19. Oh, so what's FF15? Oh yeah, FF15 would be the sweep for the first one, but it doesn't have it. Okay, so here I'll do .0. Okay, this needs to be use size, I see. .1 use size. Control if let thumb sweep that sweep.counter equals that. Yes, good job. Okay, and then here duty cycle is FF11. Well, but this is going to be the waveform dot address. Pre-divider. Okay. Oh, I still need this. 0.0, 0.1. Oh, and this is the sweep. This is the sweep. Well, the sweep only happens for that one, so I'll leave this hard coded for now. Duty waveform, self address, envelope, self address. Okay. In theory, we should have I don't even know what. Oh, yeah. In theory, I should be able to now output only the channel 2. Which will probably only play when we start the game. It's freaking glorious, my guys. Besides all of the okay, what do I need to do here? So do I do channel 1 plus channel 2 divided by 2.0? Do I like average both? Do I just add both? What the hell is this? I don't know. Mismatched types. Okay, so now we should have both sounds. Okay, get ready to this. This is gonna be freaking glorious. Oh man, this works so beautifully. kind of sounds very distorted, you know? Because it's like clipping a ton. Oh my god. It's probably a little bit too loud to you guys, no? I mean, it's fairly in sync, by the way. Like, whenever something happens in the game, it's so painful. Okay. Are we ready for the star? Okay, we're getting the star now. So fucking good. It's so good. It's so freaking good. I can't tell you how amazing like this all feels. Look at this, an entire sound wave. It's obviously like clipping a bunch of times. Well, I don't know if it's like clipping or what the hell is actually happening. But I mean, it's freaking glorious. Look at this beautiful wave. Well, it has like a tons of wishes, you know. Now I kind of want to record. Now I kind of want to record like both tracks separately. Look at this, like with all of the fade in, fade outs. Doesn't look like it's clipping. Yeah, but the sound that it's coming through, it does clip. Well, it's probably not clipping. It's probably like these weird artifacts where it still doesn't have like enough stuff to render, you know. Probably something like that. Like for example, in this case, it like missed 2, so it goes from 0 to, well, it essentially clips whenever there's like this lack of data for some reason. Oh, so I can actually like grab here at the top. Oh my god, I'm so happy. I'm so happy. Okay. Do we want to do the third one now? I mean, it should be fairly simpler. You could make the first Game Boy with Dolby Atmos support. Surely. How many channels does a Dolby Atmos like actually use? Like 200 or something? I don't even know. It's object-based audio format. Yeah, well, sure, but 7 plus, yeah. Oh my, I'm so freaking happy. Yeah, but I still wonder what the hell is happening whenever like some data misses, you know, like here, for example. Why would this happen? Yeah, I don't actually know. I don't actually know. Oh, now we get to try something else. Now we get to try. Where is it? Tetris. Let's hear the soundtrack for Tetris, you know, for nostalgia's sake. It's so good. Ay ay. It crashed. It crashed. Why? Who crashed my beautiful emulator? What the hell? Self counter plus equals 1. Ah. Oh. Well. I think it's probably this. Nope. Surely. Okay, let's see. Oof. Oof. Sounds amazing. Sounds freaking amazing. Very noisy. Very noisy. Yeah, I wonder if using the like smoothing, like the high pass filter, if this is actually gonna solve it or what. Oof. Okay, this is kinda there. I mean, I don't think I need rand anymore. Yeah, just wanna get rid of random generator. Goodbye, sweet prince. Very cool. It kind of feels like it's slow, you know? Weirdly enough. I don't know. Okay. Channel 1 and channel 2 are done. Okay. Do we want to do channel 3? Surely. Surely this is going to be easy, you know? Surely. Sample. Okay, so channel 3. what type of channel is this? Do I even know? I'll probably need to pass the config. It's a wave. Channel 1 is a wave channel. I mean, I'm already generating a wave. Surely it's gonna not be that complicated. Wave channel. Okay, I think I want to yoink. Well, not the envelope stuff. Not the sweep stuff, only this stuff. Okay. And I want to do a wave channel, you know? A wave channel. Doesn't have a sweep, so I can get rid of the sweep. It has a period counter instead of a duty waveform. The waveform is going to be a duty waveform. But here apparently it's just a regular wave. And then instead of an envelope, it's called volume. Okay, so we'll need to create two different types. Okay, then we have the sample rate, the period control stuff, period divider samples. All of this should be kind of similar. I think that for the wave channel, the length is different. The timer length. I think it's not 64, it's like something else. I saw it somewhere. Where is it? I know it said something like 64. 256 for the wave channel. Okay. Okay, so this is going to be a wave channel. I'm going to leave all of these here. This is going to be a waveform. Well, this actually has a bunch of different registers. Initial length timer. Well, because this is the only wave channel, I kinda don't need to pass this stuff. Okay, the periods I do need. So it's 1D and 1E. And they behave the same. This volume will take a 1C. Probably 1B or something. I don't know. Okay. I have no idea. What's wrong with this? Duty cycle register. What's wrong? Oh. Yeah. We will manage. Okay, let's see how. Let's see what we need to actually do now. For the wave channel, I think we'll need to do some reading now. Okay, these are the global control registers that I do not care about. And then I have sweep, length timer, and duty cycle, volume, period, pulse, which is exactly the same. And then wave output. While other channels only offer limited control over the waveform they generate, this channel allows outputting any wave. It's thus sometimes called a voluntary wave channel. While the length of the wave is fixed at 32 samples, 4 bits each, the speed at which it is read can be customized. It's possible to shorten the wave by either feeding it a repeating pattern or doubling each sample and doubling the read rate. It's also possible to artificially increase the wave's length by loading a new wave as soon as the whole buffer has been read. This is sometimes used for full-on sample playback. Okay. This register controls channels 3 DAC. Like other channels, turning the DAC off immediately turns the channel off as well. Okay. FF1B, channel 3 length timer, write only. This register controls channel's length timer.
That was good. Can you please take
Okay.
a picture? Sure.
Okay, so whenever I get this trigger here, come on. No usage is found. What do you mean? FF19. Oh. FF1E. Length enable. Okay, control. Okay, this is the length enable. And this is the address for the for this. It's actually gonna be initial length timer. What's this? The entire thing. Congratulations. No. It's not here. This one is proper. I mean the other one. No, this is the wave channel. This is... Never mind. initial length timer. Okay, so this is works properly now. Okay, so I'll need to create like some sort of waveform. So I already have the duty waveform here. So we'll kind of need to do the same thing. Waveform. Okay. This channel lacks the envelope functionality that the other three channels have, but has a much more coarser volume control. Gotcha. Yes, sir. Envelope this. Oops. Okay, so instead of envelope, it's actually going to be called just volume. Volume. Okay, so I'll get an address. I don't have a counter. I don't have an initial volume. I don't have anything. I just have a volume and a value. Output level controls the channel's volume as follows. I mean, yeah, pretty cool. Okay, so where do I do this? FF1C. Okay, cool stuff. So I'll read this and then volume or new volume is going to be this volume register. Shifted 5 times. 1, 2, 3, 4, 5. Good job. And this is the new value. No, this is the... Okay, now I need to do a match. Volume bits or bit mask. And then I do a match on bit mask. And if it's 0, 0, volume is 0. Cool. If it's 1, it's 1. If it's 10, then it's 0.5. If it's 11, it's 0.25. If the samples read from wave RAM write twice. I don't know what this means. Self.volume. Apparently this controls the volume and something else. I don't know what this means. No, it's bit mask. Okay. Volume or a bit mask. You wait. And then bit mask 0. Okay. Well, you can kind of do this directly. And then here I do volume equals that. I mean, this volume is always an F32. 0. Okay, I don't have direction, neither I have counters, neither I have anything. Okay. Okay, this part apparently was easy. So this just reads from that address, it right shifts 5 times, gets the bit mask, and then this. Oh, but this guy runs at a different rate. You see? This guy runs at a different rate. The waves channel period divider is clocked at this. Oh. Is it though? Okay, where do I manage this? I kind of need to like start closing stuff here. Okay, so I call this tick diff. The waves channel period divider is clocked at once per 2 dots. Oh. Okay, feels like I kinda need to have kind of feel like I need to have like an internal counter here, you know? Like this should be called this. Okay. And then I do a self.counter dot overflowing add. Oh. So I will do something like this. Where is this counter used for? For anything. Okay, I mean this can be smaller. And then here I do if self.counter modulo 4 equals 0. I do this, you know, I do this. If self.counter modulo 2, I do this. Pretty cool. Pretty cool. So this should run at 1 megahertz. This should run at 2 megahertz. Apparently I don't need the config here. So I'm just gonna remove it from there. Okay. Sound length. Yeah, tick length of channel 3, it's 256. Frequency sweep, we don't have that. Envelope sweep, we also don't have that. Okay, we have this control here. Oh. Actually, don't think we need this here. Self.timer equals. Okay. So I have here the period divider stuff, and that. On the wave channel, this needs to be called at 2 megahertz. Okay. I'm going to do this 2 times this. Wave pattern RAM. Holy. Okay, so we actually have 4 bytes. No, we have 16 bytes. Pretty cool. Okay, I kind of want to figure out how the wave channel actually works. Channel 3 has an internal sample index counter. The sample index increments at the channel's sample rate, which is 32 times the channel's frequency. Okay. So whenever it does this, each time it increments, the corresponding sample is read from wave RAM. This means that sample 0 is skipped when first starting up. Channel 3. Channel 3 does not emit samples directly, but stores every sample read into a buffer and emits that continuously. Retriggering the channel does not clear nor refresh this buffer, so the last sample ever read will be emitted again. This buffer is cleared when turning the APU on, so channel 3 will emit a digital 0 when first powered on. Channel 3 output level control does not in fact alter the output level. It shifts the digital value it's outputting, not the analog value. Oh, this only matters when changing the setting mid-playback. The digital values being shifted bias them towards 0, which biases the analog output towards 1. HPF will smooth these over time, but not instantly. No idea what that meant. I think that what that meant is that we don't actually have a value here. We just have like some sort of, well, I can use this, but okay. So let me think about this. As the channel 3 plays, it reads wave RAM left to right upper nibble first. That is F30 is upper nibble, F30 is lower nibble, blah blah blah. Accessing wave RAM while channel 3 is active causes accesses to misbehave. Yeah, I don't know what this means. Okay, so there's like a tick that writes there, and then there's this sample which skips every something. I guess that's what it means. Period counter wave. This is complicated. So this shifts one. This reads and shifts once. Oh, I see. So this will get me a value, and then I shift it how many bits, because this will be 4 bits. I see. Okay. I mean, I could literally have the same value. I legit do not care. This will work the same. So whatever value I get there, I multiply by that value. And that's what I push. Okay. How do I actually control this? Well, seems like I'm calculating this period stuff. Do I also have like a period divider nonsense? Okay, but is the period divider still 7FF? It should be, it's the 248. Trigger. The volume is set to the contents of NR32. Sure. Wave RAM index is reset, but it's not refilled. Okay, so this wave channel, we'll need to have I don't even know. gonna need to have like some sort of index. Okay, it's gonna need to have some sort of index. Whenever we trigger this, we need to say, that index, bro. Self index, nope, is 0. Yeah, self.index is 0. And the index does only go to 32, and then it overlaps. Okay. So do I have a write index and a read index? Or what? No, they need to be the same, don't they? I'm still confused on how I should actually like do this. Wave RAM. Like, do I generate this or does the... This is tough for me to understand what the hell am I supposed to be doing. While other channels only offer limited control over the waveform they generate, this channel allows outputting any wave. Voluntary wave channel. While the length of the wave is fixed at 32 samples, 4 bits each, the speed at which it is read can be customized. While the length is fixed. So I can only generate 32 samples at once. Okay. But then I can read it faster or slower. I would assume depending on this tick here. Maybe that's the index that I need to reset. No, so whenever I call this tick, it actually increments by 1 modulo 32, and the speed at which we read from that will depend on the period and the period divider and all of that nonsense. Pretty cool. Then, well, now my only question is, what do I actually sample from here? Well, I'll know that if I divide this and then I do a... So if I divide index by 2, it will give me an offset, which then I will need to start at FF30 plus that offset. Let nibble equals self.index modulo 2. Okay. So this will need to be the sample that I read. Read memory map. This. So I need to read this. So far so good. But then my actual sample will depend on the nibble, you know? And if nibble is 0, then my sample will shift 4. If my nibble is 1, Then my sample is only the first 4 things. 0B. Okay, so this is pretty cool, I guess. And then I kind of return this sample like this. But how do I actually write there? As the channel 3 plays, it reads wave RAM. Okay, but this is the reading. This is the reading. When do I write this? When do I actually generate the wave? Well, the length of the wave is fixed. The length of the wave. I'm so confused. Like, who writes there? You know, who writes to those offsets in there? Well, the length of the wave is fixed at 32 samples for bits each. The speed at which it is read can be customized. Okay, so it's like the wave kinda like fixed or something, and then I just modify the you know. I can't understand how the wave data is generated though. Is it like the game that puts data in there? Channel 3 has an internal sample index counter. Yes. Sample increments at each channel's sample rate. Yes. 32 times the channel's frequency. Each time it increments, the corresponding sample is read from wave RAM. This means that sample 0 is skipped when first starting channel 3. I'm confused. So this is FF30 plus something. Memory map. IO registers. Wave pattern, RAM. So this is a IO. I have no freaking idea. They keep talking about wave RAM and wave RAM and wave RAM, but reads. Okay, but who puts the data there? Who puts the data there? Channel 3 does not emit samples directly, but stores sample read into a buffer. Channel 3 does not emit samples directly, but stores every sample read into a buffer. Okay, so this is sample read, which is not sample written. I'm fairly confused. Produces arbitrary user-supplied waves. Oh. So it's literally the game that supplies the waves. Is that the case though? That would feel weird. Weird as heck. That would feel weird as heck. Okay. Do we have... Maybe I need to find... what are you doing now? Yeah, I'm trying to figure out this wave channel thing, because I thought that I would be the one like generating the wave, but apparently the ROM writes that data into a specific register, and then I just read from those index. So I'm pretty sure this should be kind of working. The only question I have now is which game can I use that I am certain will have like the wave, the channel 3 enabled, you know? How do I know if the channel 3 is enabled? You know, I have no idea. Like now I can disable channel 1 and 2, so now it should be only outputting channel 3. But yeah, I don't know if like this game is not doing anything there. So maybe I will jump to Super Mario. Or maybe play like a demo scene or something. But yeah, I'm trying to essentially figure out if I can find a game that actually generates this. Okay, apparently the Game Boy does. Apparently the Game Boy does. Volume is 0. Okay, so there's some sound effect on the Game Boy that should output a wave. Which one? Absolutely no idea. So I kind of feel like I'll need to play the game a little bit and try to figure that out. Oh boy. Boop. If not, I can just like grab a some weird ROM that might have it, you know? But I mean, this should be doing something, but it isn't. No, I don't hear anything. Not even here. Not even here. I don't know. I think I'll need to find like a different ROM that might actually have this, you know? Look at this speedrunning. Whoa. Speedrunning demon. GG, I died. Okay, is there some like audio editor or something? Gameboy cartridge wave audio wave channel. Gameboy sound wave channel. Okay, is there something that I can actually use? Gameboy square wave channel. Yeah, the issue is like trying to figure out which game would use this. Making a wave instrument. Composing notes.
What's going on? What's going on? What? I don't understand what's going on here.
This song is pretty cool as well. Yeah, maybe I'll need to try like a different demo scene or something. Just to see if any of them has sound or something. But I literally just want to hear like the third wave. Fish. Quartet. Oh, it's actually a game. Practice. Oh, this looks like legit.
I don't understand what's going on here.
The hell? Full face. Face. Damn.
Give me a break. Give me a break.
Pretty cool game. Face. Okay, so this thing actually plays as well, but it doesn't actually play a wave sound. So how can I get the wave sound playing? I mean, it's pretty cool that I can like load a random cartridge. DMG sounds, holy. Tons of issues with timing, apparently. Whatever this means, this DMG sound test. Oops. It actually looks like it's go like forever, which doesn't look proper.
I don't understand what's going on here.
Can I find cartridge for the Game Boy that allows you to like to test Game Boy Color? What do you mean? Game Boy Color detected. Good job. I only want one for the sound. Game Boy emulator test sound. Noise test. Of the noise channel. Oh. Yeah, but this is the noise channel. I kind of want more stuff. You know, I kind of want more stuff. Super Game Boy. Nah. Amazing how there's not a single freaking emulator that actually runs like all the tests of the original hardware without failing. Crazy stuff. Yeah, it's legit crazy. It's the charm of the hardware. Okay, is there a Game Boy doll? Like a DMG doll? Ultimate Guide creating chiptunes on the Game Boy. Like, I just want ability. I just want the ability to like generate noise, you know? or at the very least have a cartridge that I'll know for certain that will have waves. Okay, let's ask ChatGPT. Does ChatGPT, can you tell me? Can you give me a list of Game Boy DMG games that make use of the wave channel 3 of the APU? I'm building my own emulator and I want to validate if that channel 3 actually works. Okay, let's see what they say. Pokemon. Okay, I mean, we can try and grab Pokemon. Not sure if Pokemon is actually gonna work or not. But I guess we'll find out. This will actually be a good test as well for our memory banking situation, which I'm not exactly confident on. So let's see. Let's see. Hello? Oh. Pokemon. Super Game Boy enhanced. What does that mean, my guy? Okay, mute. Wow. Not playing anything. I can't hear shit, you know? I can't hear shit. Okay, it actually doesn't skip from here. So we are missing more timing stuff. Okay, so I still cannot play Game Boy. I mean, I kind of just wanted like a freaking... Like, is this guy generating me a Game Boy ROM? I mean, that would be pretty legit. Are you just like spewing random stuff? For fuck's sake. How do I actually know if this is like literally doing like something? So if I put a breakpoint there and I try Pokemon again, I mean, I'm pretty sure like the beginning of Pokemon would have like some fairly fancy audio. But apparently not. Apparently not. Like, is this even getting called here? It is, but volume is coming as 0. So it's actually reading stuff from there, but then the volume is coming as 0, which is odd, you know? Okay, so what if I say that let's halve this. Okay, let's see if we can actually like hear something. Pretty cool. Pretty cool. Kind of felt slower. Way too slow. You know? Kind of felt way too slow. Okay, let's try again. But for some reason, the volume is coming at 0. But it should be playing there, apparently. Okay, I should probably try and enable everything so I have a better idea of what the hell this should sound like, you know? Something like this, okay? I mean, keep in mind all of this is going to be very annoying, but I'm pretty sure everyone else has muted the stream. Pretty cool. Okay. Okay, it's doing something, but the sampling is kind of weird. Sampling is kind of weird. It's tough to me to like actually know if this is working as intended or not. Because I mean, I shouldn't have to do any of these, you know. I shouldn't have to actually modify the volume here because volume should be coming as a wave channel. Like should be coming as this bit mask. It's so freaking loud that it's crazy. Can I actually like read something from here? The hell? Why didn't these stop here? FN tick. Oh. Am I not calling volume.tick anywhere? Well, that would explain it, wouldn't it? Volume.tick. Yep. Tick envelope sweep. Gets called once every 64 hertz. I mean, channel 3.tick. Yeah, probably here I need to do volume.tick as well, just so it like updates this internal register stuff. Okay, that's maybe that was the reason why it wasn't playing like any audio. Okay, let's see. Okay, so now it's playing audio. So this is good. I think, what do I need to do here? Well, maybe I can go back to the Super Mario, because apparently Super Mario should have this enabled as well. You know? And butting. Okay, so it's generating some audio for the waves. But apparently, oh, this is neat. What are you using for rendering? Hello, welcome to the stream. I'm essentially outputting like all of the pixels directly. I'm using Winit, assuming you know Rust, but I'm using Winit to render like the window, you know, to handle the window like creation and stuff. I'm using a PNG as the window itself. Okay, so let me open here GUI. So where is this? So the actual window. Hello, can you comment out? Okay, let me add some music. But the actual window you see is like transparent, and I'm rendering the Game Boy transparently here. But then if I remove the decoration, then it looks really cool. Just looks like the Game Boy, you know. And then essentially, I'm doing the emulation where I'm essentially calculating what are the pixels that should be on screen. And then here I copy the what's it called? Like the texture from the image to the window. So if I disable this, I don't have the Game Boy at all. You know, I only have this. So this is just literally reading the pixels from an image and outputting it to the frame buffer on the window. And then I have the same thing here, but here I only replace the actual like a square. Where it's green, I'm just drawing it like white on top with the actual pixels that I get. So I'm not using like anything fancy. I'm just calculating data and writing it here like on the proper place. Tiny dependence list. Love to see it. Yeah, it's pretty tiny. I mean, the idea was that I really wanted to do pretty much everything on my own. So CPAL essentially, can I even add comments here? So CPAL is like the audio library, which outputs to like speakers, you know. Then this is a wave file saver, which means that I can output to a .wave, just so I can like analyze the waveform like I have here, you know. Can do this. Yeah, and then these three are for the Well, winit is for the window creation, image is to load the PNGs for the background, and soft buffer is essentially how I interact with winit to actually put the pixels in there. So yeah, for the Game Boy itself, for the Game Boy emulation itself, there's 0 dependencies. All of the dependencies are to interact with external devices. So for the screen, for the Windows like rendering, I'm using these 3. And then for the audio rendering, I'm using these 2. But everything else is handwritten code. Yeah, so the standard native window transparent layout virtual title bar controls. Remember doing similar back in 2004 with VBA, Visual Basic 6. Oh, that's cool. So you are writing directly to the buffer. Exactly. I mean, this is a fairly simple console, you know, so there's really no point in having like OpenGL or whatever graphics API you might want. So, yeah, I like this. Yeah, frame rates don't need to be insane for Game Boy either. I mean, it still needs to run at 60 Hertz, you know. But I mean, every console until like the PlayStation 3 or even PlayStation 4, they run like at a locked 60 frames per second, you know. Only the PlayStation 5 like actually started doing like something different with either 120 or a 60 or 30 even, depending on the type of game, if it's a Ultra HD or not. But I mean, the frame buffer is so small. It's for the Game Boy, it's 160 by 144. So things move fast here. And yeah, I mean, I'm working on audio, which is something that I've never done before. I think I can give you like a small demo in case you have experience with it or not. I don't know. Sample. Okay, I'll do this. Okay, I'm gonna disable the third one because the third one is what I'm trying to like actually implement, and it's not working properly now. But yeah, I play the chime at the end of the boot ROM and magnifier, and I mean, pretty cool. I mean, it sounds weird, you know. It has like tons of digital artifacts to it because I still need to pass everything through a high pass filter and then it will like move it out. But yeah, essentially if I now stop this. Hello, can you stop? Thank you. If I now stop this, you'll see that I actually generated the entire wave file for that. So I can replay it. You know, and I can like test how things are. I mean, it's pretty cool. This is the the audio from the emulator. But yeah, I've been essentially looking at waveforms and try to figure out if they look proper or not. So that's why I integrated this with the a wave file exporter, essentially, which is the library that I have here, the Hound. And now I was trying to figure out the channel 3 stuff, you know. I was trying to figure this out. Essentially. I mean, I can probably do something like this. And then this make it a little bit less annoying. Because the wave one it's tough. Design-wise, it seems solid. My immediate next step after having it working would be to make a debugger, lol. Yeah, I thought about it. I thought about Why is he not playing any music? Okay. I thought about probably integrating it with a GUI, you know, because then could have like a. It's not working. Oh, because then I could have like visualization into like the actual RAM of the game and see how the sprites look in RAM and that type of stuff. I've never actually interacted with a GUI, by the way, so no experience there, but I think it would be pretty cool. I could have like a memory editor as well. I could have like toggles to actually play with the different audio levels for the different channels. I mean, a bunch of stuff, really. Yeah, I have some experience with EMGUI, which I want to believe it's similar. But this is a C++ and this is Rust native. So yeah, plenty of stuff. I know nothing about audio formats. I played with Celt a bit when reversing Counter-Strike's replay functionality, but beyond that, I have virtually no experience with it. Did they remove it from the main Z codebase yet? Also add, be able to hear you for 3 minutes. Okay, let's see if we can actually get some sound here. This is very obnoxious, you know. Can I make it even less loud than this? Yeah, so still trying to debug these this third channel situation here, which is doesn't sound that great. Okay, I'll try to make it even less loud. Okay, do we actually have... Does Tetris actually use this? Okay, welcome back, I guess. Did they remove it from the main Z codebase yet? I don't actually know. I don't actually know. I know nothing about the Z codebase and the eGUI. Don't know any about that situation. But what was the issue there? Did I like the Z editor use the emGUI or something? I don't know. A GUI was only usable by including a huge chunk of the Z codebase in your project. GUI was built for Z. Oh, I see. Well, then I have no idea. I have no idea. I actually don't know how large will it make for the project to include this. Where is Cargo Toml? great, all the GUI stuff. I mean, so many freaking dependencies. Look at this. I mean, it's surely like a giant project. There's a decent third-party lib, GUI components. I think it was called, kind of ShatCDN-like. I see. So this one is like a smaller version of it. Or this is like just components built by the community that adds like stuff. Probably that. Or a totally new thing. Cargo Tomo. GUI. Modern non-intrusive component library. Okay, so it's essentially a GUI with a prettier theme. With a prettier theme. I see. Yeah, maybe it's not this one. A GUI. GUI UI components. Yeah. A GUI UIX? I don't know. No. But yeah, it would make sense if there was a small repo which included like a bunch of reusable components that you could add. Although at the same time it would be probably better if each component was its own repo, you know? Because if not, you are also importing a bunch of stuff that you want to use. I don't know. Not a GUI. Okay. GP UI. Oh, okay. Yeah, this feels way more like HTML, CSS stuff. Oh yeah. Okay, so GPUI is what they actually used for Z. I see. I see. Examples. Hello world. Well, okay, so none of these actually runs in the browser, it seems, or this is just code. Does this even compile for the browser? I don't know. Oh, it does. Wasm. Okay, I mean it's cool. Yeah, I don't know if I'll actually want to go through that route, because the objective for the emulator is that this was my first console. Okay. It was gifted to me by my grandma around 30 years ago. And I'm just trying to figure out what was the first game that I ever played on it, which was some sort of basketball game that I don't really recall the name or how it looked or how it played. But I thought, okay, I'm streaming now, I need to create content, but the goal is still to find that game. So I would say that as soon as I like finish audio, I think I'll just like find the actual game and like be done with the Gameboy emulator. I don't know. I don't know if there's actually like interest in building like a proper, yeah, something like that. I think that my plan will be to download a bunch of them, because I mean I do have cartridges, some cartridges for like some of the first games that I had, you know. So I had like Pokemon Red, Pokemon Yellow, Super Mario Land 1, Super Mario Land 2, Super Mario Land 3, which was also Wario Land 1. Pokemon Silver. I have this is one they call Tasmania, pretty cool. And I don't know what happened, but I'm actually missing that first basketball game. So yeah, I will download a bunch of cartridges. I'll download a bunch of cartridges regarding basketball. I'll try them out. I'll figure out what was the game, and I think that will be the project. Although I considered, and I'm still considering it, either one, making my own game using assembly directly, like hardcore, or two, because the Game Boy supports like a serial mode where you could connect two Game Boys one to another. For example, Tetris, Tetris has like a two-player mode, which you connect like the link cable between two Game Boys, and you could go head to head. My plan was to implement a networking layer. On top of this link cable implementation, which actually meant that if I was playing this, I could connect with someone in the other side of the world and 1v1 Tetris on my emulator. I think that would be pretty cool. I don't think there's another emulator that does something like that. I think that would be kind of unique. So yeah, but I will need to think about it. Z80 isn't hard, is it? Honestly, with Rust you could probably create a DSL relatively easily in the compiler. Yeah, I mean Z80 architecture is fairly easy. The instruction set is fairly easy as well. If I want, I can very easily convert from the grayscale Game Boy to a color Game Boy. It reuses like 99% of the code. It's just some if-elses at compile time that kind of need to happen, but it's pretty much easy. So yeah, I mean, there's tons of possibilities that I can do with this project. I just don't know if I wanna continue working on it or not. I mean, I've also been streaming for, 1 month and a half by now. Like started streaming 1 month and a half now, so I'm still like trying to figure out like my place here. What is the type of project that people enjoy watching me doing, and I can tell you that the Game Boy one is one of the streams that usually have less people working on, less people watching. I have 2 other projects on rotation. I have one Unreal Engine game and one Unity game, and usually those get more viewers. So maybe continuing working on the Game Boy would just not help. 360 opcodes total. I mean, for the Game Boy, it's I would say it's more than that. They kind of support, I mean, it's 512 minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 511. Well, originally it's only 250 or 240 something, but then there's one special opcode here, which is called prefix. Whenever you get OXCB opcode, then you have the next byte will tell you what is the next function that runs. Yeah, it uses like the prefixed stuff. It's like ARM modes. maybe. But yeah, it's the first emulator that I'm working on, and I'm really enjoying it. Yeah. I still need to figure out if I'll code my own game, or if I'll add the multiplayer, or if I'll do the Game Boy Color implementation. I mean, tons of possibilities and so little time, you know. But yeah. But today has been incredibly successful because at the start of the day, I had tons of audio code written, but none of it was actually working. But now it's outputting audio. ARM assembly, similar ULab like byte or bit field prefix with changes behavior. I see. But yeah, at the start of today, I had a ton of code written on the APU. I mean, it's 800 lines of code. Well, it was like a little bit more than half of that. Yeah, it was probably 630 lines of code, which were written, but it wasn't generating any sound. And now they are generating sound, so that's pretty legit already. So yeah. I'm trying to figure out now what I'm trying to figure out now the third channel. So there are 4 channels on the Game Boy. The first 2 ones, channel 1 and channel 2, they are pulse width modulators, and the channel 3 is a wave channel, but it's like a user wave channel where the user, in this case the cartridge, it will write data into a specific area of RAM, and then I just play that area over and over again sequentially. It's not working properly. Essentially, it's not working properly. I mean, if I have it playing, I lowered the audio, so it's gonna be fairly difficult to hear, I think. But you have like the... Hold on. But you have like the... da 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 da, which is like these two wave channel, these two PWM channels like generating sound, and then you have like some background instrument which has to do 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 do. Okay, so these are just like the PWM channels, and these are running like in real time, so they sound like this. But then this third instrument or third channel should play at the same frequency, almost not frequency, but at the same pace as the other ones. But it kind of seems like it's either way too slow or way too fast. So maybe I'm not reading data. Oof, now I can barely hear it. So yeah, that's what I'm trying to figure out now. And then, I mean, next week probably. I don't think I'll touch the Game Boy this week again. But I think next week I'll be able to finish this noise channel, the 4th channel. Yeah, so it feels like this is playing, like this third channel is playing like way too slow. Way too slow. So yeah, I don't know what's going on there, but I'm trying to figure out where that issue comes from, essentially. Now it's even worse. Now it's even worse. Now it's playing like in sync, so that this times 4 there kinda makes it work. Kinda makes it work, but I don't know. Still feels way too noisy, you know. I'm just playing with the audio level, so it's a little bit more bearable. Okay. I think I had like a link. No, for the Tetris ROM. So I like could play it here and have an idea of what it should actually sound like, you know? Downloading game metadata. Yes, sir. Okay, maybe it's not loading here. Failed to download. Okay. Now it's going. Let's see what this sounds like. This is gonna sound good, obviously. Okay, so it actually feels like I'm, for some reason, way too slow on the generation of this data, you know. Like this tick here. Maybe it's this. Nope. Whatever this is doesn't sound better. Okay, so there's still something weird here with the timing. It still feels way too slow though. Maybe I can just get rid of this, like honestly. What would happen? What could possibly go wrong if I get rid of that? Oof, no, it's way too slow. I don't know. I'm doing something very, very wrong though. I'm doing something very, very wrong. I actually thought this would be this, you know? I don't know. I don't know. I mean, but it's kind of generating the wave sounds now, you know? It's just sounding bad. But it's generating stuff. Okay. What if we try the Pokemon cartridge? Yeah, it's sounding weird. It is sounding weird. I mean, I think I can disable the writing for the wave, you know, for the wave file, because that's probably what might cause that as well. I don't know. Let's see if this improves something. I don't know. I don't know. I mean, it's outputting something, but whatever it's outputting is weird. Whatever it is outputting, it is weird. But yeah, in any case, I think I'll cut the stream here. I think I'll cut the stream here. Yeah, I think I'll end stream here. I was trying to figure out if there's like something else that I could work on that would be smaller, but not really. I mean, it has been a long day, so thank you everyone for watching the stream. I hope you enjoyed the content. I know it's a little bit tough hearing like to audio noise pretty much the entire day. Yeah, because it's mostly sounds like garbage most of the time. But I mean, it's part of the streamer life, of the developer life. Yeah, but I do understand that working on the games themselves, or just like on the visual rendering, is probably a little bit more interesting. But I mean, it needs to be done. This still needs to be done. For the ones of you that do not know or do not yet joined, I do have a Discord server, so if you are interested in talking with the community offline, we can keep the conversation going in there. But in any case, I appreciate you all for watching the stream, for keeping me company, and I'll be back tomorrow morning. And I would say that tomorrow morning I'll probably work on the Unreal Engine game. Is it? Maybe. Yeah, I think tomorrow morning or tomorrow the entire day, I think I'll do the Unreal Engine game. Thank you everyone, and I'll see you next time. Bye bye.